Good day. In this video, we'll explore right triangles, one of the fundamental shapes in geometry. A right triangle is a triangle that has one angle measuring exactly 90 degrees. We'll learn how they work, why they're important, and how to solve problems involving them using tools like the Pythagorean theorem and trigonometric ratios. To find the value of this example, notice that we have right triangle, so we can use Pythagorean theorem. Pythagorean theorem states that the sum of the square of the length of the legs of the right triangle is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared, where a and b are the lengths of the legs of the right triangle, and c is the length of the hypotenuse. So here, since the legs of the right triangle have 6 and 8, and the hypotenuse has a length of x, we can set up the equation 6 squared plus 8 squared equals x squared. Simplifying from here, 6 squared is 6 times 6, or 36, and 8 squared is 8 times 8, or 64. So we have 36 plus 64 equals x squared. Next, 36 plus 64 is 100, and we have 100 equals x squared. Now, to get x by itself, since x is squared, we take the square root of both sides of the equation. On the right side, the square root of x squared is x. And on the left, since 100 is the perfect squared, or 10 times 10, the square root of 100 is 10, so 10 equals x. Notice that we don't use plus or minus 10 because x represents the length of the hypotenuse of the triangle, which cannot be negative. So, the value of x is 10. Trigonometric ratios relate the angles of a right-angled triangle to the lengths of its sides. There are three main trigonometric ratios: the sine theta, cos theta, and tan theta. As we can see, we are given a right-angled triangle with the following lengths. One side is 3, another side is 4, and the hypotenuse is 5. This satisfies the Pythagorean theorem. 3 squared plus 4 squared equals 9 plus 16 is equals to 25 equals 5 squared. To get this, 3 squared is equal to 9, 4 squared is equals to 16, and 9 plus 16 is equals to 25. And the exponent of 25 is 5 squared, or 5 times 5. So, it's a valid right triangle. Let's proceed to step 1. Step 1. Choose an angle. The opposite side is 3, the adjacent side is 4, and the hypotenuse is 5. After choosing an angle, let's proceed to step 2. Step 2. Define the trigonometric ratios using the three main trigonometric ratios. First, sine theta, opposite divided by hypotenuse. Second, cos theta, adjacent divided by hypotenuse. Third, tan theta, opposite divided by adjacent. Now, let's proceed to step 3. Step 3. Find the value of each ratios. Sine theta, 3 divided by 5 is equals to 0.6. Cos theta, 4 divided by 5 equals 0.8. Tan theta, 3 divided by 4 is equals to 0.75. Now, Let's summarize the final answer using a table. Trigonometric ratios: sin theta, cos theta, and tan theta. The formula: opposite divided by hypotenuse, or 3 divided by 5. Adjacent divided by hypotenuse, or 4 divided by 5. Opposite divided by adjacent, or 3 divided by 4. The value: 0.6, 0.8, and 0.75. When setting up a ladder against a wall, it's important to place it at the correct angle so it's safe to climb. Safety guidelines often recommend that for every 4 feet of height, the base of the ladder should be 1 foot away from the wall. A ladder leans against a wall. Height up the wall: 4 feet. Distance from wall: 1 foot. We need to find the length of the ladder, or the hypotenuse. This forms a right triangle with vertical leg is A, equals to 4 feet. Horizontal leg is B, equals to 1 feet. Hypotenuse is the C, and it's missing. Using the Pythagorean theorem, A squared plus B squared is equals to C squared. Now, let's substitute the known values. 4 squared plus 1 squared is equals to C squared. So, we have 16 plus 1 is equals to C squared. Now, let's solve for C. 16 plus 1 is equals to C. So, 17 is equals to C squared. Now, let's proceed to finding the square root of both sides. The square root of C squared is C, and the square root of 17 is 4.12. So, the value of C is 4.12. So, the final answer is the length of the ladder should be approximately 4.12 feet to safely reach 4 feet up the wall and at the correct angle.